Welcome to myprojectbazaar.com. Our product title is Optimal Geometric Control of DC Microgrids. Now we are going to discuss about our product abstract. In our process mainly we focused for DC to DC troop control common method for power systems. We having the source of the voltages for two DC source, and then bus system based the current and voltages, linear and process drooping controls of systems. And then we focused for the which one the best one, the DC to DC operating systems based on the small scale power systems with using the DC microgrids. In the microgrids main the my power grid, and also operate the isolated of this DC conversion of the changing the source, each and every and current source of the reference, and determine that linear relationships. The traditional troop controlling and optimization of these both conditions between the source of the multi-level and troop control of the common method in the power systems. The control of have been limited the linear or based current and voltages bus systems, and make that DC source of multi-level. In the both DC source of input source, we getting the analyzing the DC to DC converting the process. After we getting that which one the better of the DC source and high efficiency of the linear based some voltage sources, and alternate that, so optimize and traditional group control systems of implementations. The traditionals and group controlling of the both are linear based of the reference parent and bus voltages in the relationship between the microgrids. Now we are going to discuss about our product flow diagram. In our process we mainly focus for the DC source and 1 and DC source 2, and we are getting the voltage bus systems. Here the way we are getting that converting the process DC to DC, and the voltage bus systems having the three-phase measurement of that both current and voltage measurement of the scope model, and loss finally we getting that resistor load. So which one the optimal system than traditional drooping control systems, we make that the DC which one better of the result in the DC source the microgrid. So mainly for DC microgrid is a storage functions for that energy efficiency for the power calculations, and then mainly the which connecting the load connections, resistor connecting, and then power calculation also the DC microgrids, which one the possible of the DC energy source in the conversion of DC to DC and DC to DC boost buck and boost converting the process. So bidirectionally we connecting that only the direction in direction for the buck and boost and buck converters, and then another line DC source having that DC to DC buck and boost converting process in the bidirectional for voltage bus to DC source the input both in 1 and 2 power calculation. So this level of the main consideration, the microgrid DC microgrid based the source of analysis in the optimization and traditional loop condition of this process. Now we are going to discuss about our product running procedure. In the DC to microgrid storage functions mainly implemented using MATLAB 2013 version and Simulink software tool. Here the Simulink tool implementation mostly we are using the power electronic based library functions almost. So here this is a Simulink library browser which we want what components of our process need, we are searching from here. After the connecting the as per the designing of the papers, so DC sources and bus systems, and converting the process in input DC source voltage measurement, current measurement, and then converting the process, and then using that DC load, DC power load, the resistor load, RLC load. So whatever we want to the connecting the devices as per the process. So here is searching all devices component, searching from here getting the completed designing. After we output result, so output result maximum we going to show that scope model based. So scope is available for this each and every scope where we want one place to another places. We are connecting in between of the current and voltage measurement. We using the voltage measurement and current measurements tool devices. So connecting to scope model, we will be getting the output of the point of output voltage and current and power, whatever we want to highlight that scope model. So after finishing that process completely, we want the main important for one thing, the component for power guide. So why we want to using the power guide, because this simulating tool power whole panel using that power, we want giving the power. So using the power guide, so we using that power guide, we are getting the like AC or three phase AC DC source. So what are we connecting the main supply from here, that whole panel for supply for power guide. So this is important for the power guide. After complete the finishing process, just so run the button. This is the run the button, just click that run, and after we getting output of the scope model. So we click the scope and getting the output of the each and every output transmission line. So I go show the output of this process. Oh, this is a single V not one. This is source. So this first I give the source of the scope 1. So this is just made the okay. This is a voltage source of input correction input. This is so voltages and load of output voltages, and then power of voltage power DC microgrids of power load connections. So all output of the process inverted to the buck converters, and this is the boost converters. This is the level of microgrids. This is the inverting 2 of process. So last finally we getting the transmission line for the microgrid based power qualification. So here 3000, almost 3000, 2958 point something like output of power getting the optimized and the traditional loop controlling process. So this kind of output, the DC microgrids is mainly using the energy storage of the functions. So thank you for watching our video.